Hi everyone, today we are talking about adding and subtracting in scientific notation. As a reminder, you do not need to write down everything we discuss in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause to jot down important notes, rewind to view information again, and fast forward if you think you got it. Just be careful and be sure that you don't fast forward too much that you miss out on anything important. So let's begin. Today I'm going to show you a trick on how to add and subtract numbers in scientific notation. It is a little bit similar to your multiplying and dividing in scientific notation. However, just like adding and subtracting normal whole numbers, it's a little bit different. What you need for this trick to work is your powers of 10 to have the same exact power. They need to be matching. So if you have 10 to the 8th power for one, the other one has to be 10 to the 8th power as well. Why is that? Because when we're adding and subtracting numbers, you always line up your place values. And powers of 10 tell us place values. So just like normally adding and subtracting numbers, you have to match up your place values, or your powers in this case. Go ahead and pause and write this down in your notebook if you haven't done so already. So what's the trick? Adding and subtracting in scientific notation, there are 3 steps. Go ahead and jot this down in your notebook. The first step is to make sure both numbers have matching powers of 10. If they don't have matching powers of 10, you're going to move the decimal place to the left or right to make the matching powers of 10. But since you're moving your decimal to the left or the right, you have to make sure that your moves are balanced. So you'll need to balance it out by changing your power of 10. We'll go over that later. Then you're going to add or subtract just the first part of both numbers, kind of like multiplying and dividing. And then you're going to keep the power of 10 exactly the same in your answer. So let's go over some examples. For this first example, we have 5 times 10 to the 8th power plus 3 times 10 to the 8th power. These powers are matching. The first number is times 10 to the 8th power. The second number is times 10 to the 8th power. So since they're already matching, we can go on to the second and third step. We add or subtract the first part of both numbers and keep the power of 10. We just add 5 and 3 to get 8. And since they both have times 10 to the 8th power, it stays times 10 to the 8th power. So the answer is 8 times 10 to the 8th power. 5 times 10 to the 8th power is the same as 5 with 8 zeros behind it because of the place values, 8 place values. 1, 2, 3, 4, 5, 6, 7, 8. And if we're adding 3 times 10 to the 8th power, it's just 3 with 8 place values behind it. So then adding the 5 and the 3 together is the same as adding this 5 and 3 together. So you get 8. And then keeping the 10 to the 8th power the same for both of them is basically like putting down all these zeros for the place values. There's no need to do any math if those powers of 10 are already matching, because just like in normal addition, when you line it all up, you're not really doing any math. You're just keeping it the same. So our next example is where the powers don't match. We have 5 times 10 to the 8th power again, and this time it's being added to 3 times 10 to the 7th power. Now these powers are not matching, so we're going to need to make them match. And the reason is because 5 times 10 to the 8th power has 8 place values behind it, but 3 times 10 to the 7th power only has 7 place values behind it. So they're not matched up. We can't just add 5 plus 3. This answer is actually 530 million as opposed to 800 million. So instead of writing this all out, you can use the shortcut that we talked about up here, which is moving the decimal to the left or right and making sure that our moves are balanced. So we're going to talk about that. If we're changing 3 times 10 to the 7th power, and we want to change it so that the 7th power is matching the 8th power, we would be adding 1 to 7. We're moving 7 to the right 1. It's going up 1. Since we're doing that, we need to balance it out. We can't just make our power bigger by 1 and then assume that our answer is the same. It's not. We've changed it. So in order to balance it out, if we move 1 to the right for the power from 7 to 8, we're going to have to move 1 to the left for the first number. The decimal point was originally behind 3, so now we're going to move it up so that it's in front of 3, 1 place. So 7 got moved 1 to the right. It went from 7 to 8. And now 3 is going to move 1 to the left to balance that out. So it's going to be 3 changed to 0.3. So now this is 0.3 times 8 to, so it's 0.3 times 10 to the 8th power. So if we had that decimal point in front of 3, it would have moved over 1, 2, 3, 4, 5, 6, 7, 8. Okay? So by moving an extra place value, it changes the number in the front to a smaller number. Now we can add it up. Now they have matching powers of 10, 10 to the 8th power. So we keep that in the answer, and then we add the first part. 5 plus 0.3 is 5.3 times 10 to the 8th power. 5.3, that decimal will be right here. Move it over 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so when they're not matching, we have to make them match so that we can use that shortcut of just adding them. All right, let's try some examples with subtraction. In this example with subtraction, they have matching powers of 10. It's 10 to the 51st power. So we're going to keep 10 to the 51st power in the answer. And then we're going to do normal subtraction for our first parts, since they are matching. Since they're matching, that means that all those zeros line up with each other. So this is 6.8 minus 5, which is 1.8 times 10 to the 51st power. If we were to write it out, it would just be 6.8 with 50 decimal places, or place values behind it. And this would be 5 with 51 decimal places behind it. 51 decimal places behind it. And then we would ignore all those zeros. That's why we just copy down the power of 10. And then we would just look at our 6.8 minus 5, which would give us 1.8 times 10 to the 51st power with so many zeros behind it. So this is a great shortcut instead of writing it all out, because there would be way too many zeros to write out. That's why we have our shortcuts. Now here is our last example with subtraction and negative powers of 10 that are not matching. So we have 6.4 times 10 to the negative 34th power. That means it's a really, really small decimal. Minus 12 times 10 to the negative 36th power. Another really, really small decimal. These powers of 10 are not matching. So what I'm going to do is I'm going to make them match. I like to change the smaller power of 10 so that it matches the bigger power of 10. Just like up here, I changed 7 so that I could move up and match 10 to the 8th power. Here I'm going to take the smaller power of 10. That's negative 36. The bigger a negative number is, the smaller the value is, because it's further away from the positives, or 0. So this one's a smaller one. You might need a calculator for this, or you could do it on your own if you already know how to do it. Negative 36 is smaller. It needs to add 2 in order to get to negative 34 and match this one. So since we move 2 to the right so that it's bigger, we need to change the first number, 12, 2 to the left. 1, 2, so that it's right in front of the 1 in order to match and balance it out. So now we have 0.12 times 10 to the negative 34th power. They're matching. If you didn't move any place values or change this number, then you've changed the number. You have to balance it out. So we have 6.4 minus 0.12, and that's 6.28 times 10 to the negative 34th power, which they both have. They need to be matching. These types of problems is where it's going to be the trickiest, so just remember that you won't need to balance it out. If you move it up 2, then you need to move this other one down 2. Let's try out some more examples. All right, in this example, they want us to express our answer in scientific notation. Remember that scientific notation wants us to give them a number between 1 and 10. So you need to make sure that you just have one number in front of the decimal point. Go ahead and pause the video and see if you can try this on your own first. Okay, so for this answer, we're going to need to subtract. And then we first need to check if they have matching powers. They do not have matching powers, so we need to make it so that they do. I'm going to go ahead and change my 10 to the 5th power. I like to choose my smaller one so that it can match my 10 to the 6th power. That means I need to add 1 in order to get to 6. Since I am going to the right on my number line, going from 5 to 6 to the right, that means over here I need to move to the left. I moved up 1 for the power of 10, so over here I need to move down 1 for this power of 10. So now this problem becomes 2.2 times 10 to the 6th power minus 0.43 times 10 to the 6th power. In this case, I'm going to need to just do the subtraction here, normal subtraction, and then keep the 10 to the 6th power. So it becomes 2.2 minus 0.43. Let's go ahead and use my calculator. 2.2 minus 0.43, 1.77. So that math is 1.77 times, and then we're keeping these powers the same, times 10 to the 6th power. So our answer is 1.77 times 10 to the 6th power. All right. So again, what we did was make sure our powers are the same by balancing it out. Move up 1 here, move down 1 here, and then do normal math for the first part of the number. Keep the power of 10, because that's just like all those repeating zeros. But those zeros have to line up. That's why we need the powers of 10 to be exactly the same. Let me know if you have any questions as you work on these problems with adding and subtracting. And if not, I will see you in class.